So for section 2.2, we also have another method, which is called the washer method. So here the example. We have f of x equal to square root of x, g of x equal to 1 over x. Using decimals, we got the graph from the interval 1 to 3. The green one is square root of x, and then the purple one is 1 over x. We're going to having the regions between those two curves. And now for this region, we're going to rotate it along the x-axis. And after rotation, this is the three-dimensional shape we got. And one thing you noticed after we graphing the three-dimensional shape is the inside portion, it is hollow. Here is completely empty. It is not a solid disk. And if we do the same thing, we slice the object and turn it facing to us, we will see a donut shape, which means we have a circle, smaller circle inside, and then a larger circle outside. Still the inside, the reason for us to call it hollow, donuts or washer, because the inside is hollow, outside is solid. So the actual area we're going to find on this slice is actually only this shaded region. In this version, to find the area, we are going to using the larger circle area minus the smaller circle area. And the leftover is going to be the region we wanted. And we know how to find the area of a circle, which is pi r squared. So we will need to find two different r's. The outside function, which is y equal to square root of x. The inside function is y equals to 1 over x. So the area, as I mentioned, we're going to using the larger area minus the smaller area. And then the area of the circle is pi r squared. Let's fast forward it a little bit. Okay. Now we see that the r value, the larger area, is going to be the y value for the green graph, which is square root of x. And then the smaller radius, which is the inner circle, which is the height for the purple graph, which is going to be 1 over x. So to set up this particular problem, we're going to do the integral from a to b of pi, the outer radius square, minus the integral from a to b of pi times the inner radius square. We can combine them by pull out the pi and then the integral symbols, combining the integral symbols to get pi times the integral of a times b of the larger radius square minus the smaller radius square. So combining everything for this particular problem, we are going to integrate it from 1 to 3 because that is going to be our interval. Times pi, and then the outer radius is going to be square root of x squared minus the inner radius, which is 1 over x squared dx. Now we fully set it up, we can start to evaluating the volume. Pull out the constant pi to the front and square them. I like to changing 1 over x squared into x to the negative second power using the power rule. We got x squared over 2 minus x to the negative 1 over negative 1, which is x squared over 2 plus 1 over x, evaluate from 1 to 3. Which is 3 squared over 2 plus 1 over 3 minus 1 squared over 2 plus 1 over 1. And we ended up with 10 pi over 3. So 9 over 2 minus 1 over 2, that is 8 over 2, which is 4. 4 minus 1 is 3. 3 plus 1/3, which is 9 over 3 plus 1/3, which is 10 over 3. So that's why we got 10 pi over 3. Okay, we can get to another example. This time we have one function, f of x equal to x plus 2, but we have y equal to negative 1 and y equal to 0. So the region is bounded between the function x plus 2 and the x-axis on the interval from 0 to 3. So the region we have is this shaded portion. And then we're going to rotate it along the line y equal to -1, which is this black line. So once we rotate it, this is the graph we have. This is the three-dimensional shape we got. And we can see that this is a case that the inner is hollow. So if we do one slice and turn it facing us, we will get a donut shape or a washer shape again. Where the outer area R is this piece, and because we are rotating along the line y equal to -1, so the smaller r, the inner circle, is this much, which is the distance between the x-axis or y equal to 0 and the y equal to -1. So this one is easy to find, which is just 1. Then for the outer one, it has two parts. The top portions, which is the y, the function x plus 2. But the bottom portion is going to be the same as the smaller r, which is 1. So the larger radius r is actually the top portion, x plus 2, plus the 1, the smaller part. So the larger part of the area, the radius is going to be x plus 3. Now combine everything to set it up. The volume is going to start from 0 to 3. And then the pi, the larger r is x plus 3 squared minus the smaller r, which is 1 squared dx. Doing some simplifications, which is x plus 3 squared. Actual FOIL it, we got x squared plus 6x plus 9 minus 1, which is going to be x squared plus 6x plus 8. Integrate them using the power rule. We got x cubed over 3 plus 6x squared over 2 plus 8. Evaluating from 0 to 3, where 6 over 2 is 3. So x cubed is 3 cubed, which is 27. 27 divided by 3 is 9. 6 over 2 is 3 times 9 is 27. 8 times 3 is 24. Minus 0 times everything is always going to be 0. So we end up with 60 pi. So the reason for this method called the washer or donut method, because there is a hole in the center. We're going to have two different circles. We will using the area of the larger circle or the radius square of the larger circle minus the area or the radius square of the inner circle. And it follows the same thing. If you slice your object Vertically, it's going to be dx. If you slice your object horizontally, it's going to be dy. And just like the last example we had here, because we are now rotating along the x-axis or the y-axis, you do need to find your radius, taking the consideration of the rotation line. For this case, y equal to -1.